All right, so today we're talking about multiplying, dividing, and simplifying rational expressions. And we're also going to talk about the domain or domain restrictions. So I'm just going to start you off with a really simple example. If I had asked you to simplify the fraction 2 plus 1 over 2, I would hope we know that there's kind of an, unwritten rule that you can think of there as being parentheses around the top and bottom. We need to simplify the top and bottom before we do or perform the division. So in this case, of course, we would need to add 2 plus 1, which is 3, over 2. Or, of course, if we actually divide that out to a decimal form, we get 1.5, right? So hopefully we know we have to perform those addition or subtraction, anything in the top and bottom. Thinking about order of operations, there's those invisible parentheses, and you have to simplify in the parentheses first. Okay, so I would assume most people know that you can't do this, that you cannot cancel out these 2's in the top and bottom and say the answer is 1. Obviously, that is not equivalent to the true answer. So I would assume most students would know not to do that. Okay. However, very commonly, we'll see students do something very similar like this. Okay, we cannot cancel these x's out in the same way that we can't cancel these 2's out. There's an operation that has to be performed up top first, and that may not have a common factor with x. Okay, so that's why we cannot cancel these out. This is bad. Don't do this. You make kittens cry when you do that. Okay, so don't do that. The only things we can cancel are common factors between the top and bottom. In the same way that most of you would know, we can cancel out 6/4 or reduce it to 3/2, because if we were to break them into their prime factors, we can cancel out the common factor of 2. Okay, so we can only cancel out common factors from the top and bottom of a rational expression. And factors are numbers, expressions, or quantities that are held with multiplication only. So if there's still adding or subtracting going on and we can't match an entire expression, we cannot cancel things out or simplify it. Okay, so here's some steps we're going to use, and these will be repeated on the next pages. But the first thing we want to do with these rational expressions is factor the top and bottom completely. Okay, if you cannot factor them, place parentheses around any non-factorable expressions. So for instance, x plus 1 up here, in this example, I would have wanted to put parentheses around and thought of that's its own factor. X plus 1 is a factor, x is a factor, they do not match, we cannot cancel them. Okay, the next thing we do is state the domain. So hopefully you guys know there's only a few things you can't do in math, and one of them is you cannot divide by 0. You cannot have 0 in the denominator. If there's a 0 in the denominator, this is undefined. Okay, so specifically, if we were looking at, say, this expression, what would make the denominator 0? When x is 0. So your domain for this would be x can't equal 0. Okay, it could be any other number, but plugging in 0 makes the bottom 0, and our whole expression is undefined. You cannot divide by 0. So that's what it says, excludes any values that give division by 0. Okay, but once we've factored it out, we can cancel like terms or quantities between the top and bottom at a 1-to-1 ratio. Do not cancel terms over addition or subtraction. In other words, do not cancel those x's out, just like you would not cancel those 2's out. Okay, so let's take a look. I just have these steps up here again, but let's simplify each of these and state the domain. So again, step 1, factor completely. And remember, when you're factoring, the first thing you always look for is there a greatest common factor? And up top, yep, as I look in here, these both have a common factor of 9 and x. So we're going to factor out our 9 and x, and divide that out of each of these up top. Dividing it out of this term leaves me with x. Dividing it out of this term leaves me with positive 1. Okay, so the top becomes 9x over x plus 1. The bottom has a common factor of 2. So we're going to factor out our 2. Dividing it out of each of these leaves me with x plus 1. Now notice, we just went from things that were held with addition to now we have expressions that are held with multiplication. And that's what's going to allow us to look for common factors or simplify this. And in fact, we do have a common expression, x plus 1, that we're going to be able to get rid of. Before we get rid of it, though, we want to state the domain. So for our domain, what value or values of our variable would make the denominator equal 0? Well, in this case, this doesn't even have an x with it. That will never equal 0. That will always equal 2, so we don't have to worry about that. But when does this expression equal 0? Well, of course, we can take that off to the side and say, when does that equal 0? And that's when x equals -1. So our domain is all real numbers as long as x does not equal -1. Now, you don't have to write it in this specific form. You can just say x can't equal -1, and we'll accept that for your domain. Okay, this is the all real number symbol, and this bar, this big vertical bar, just means such that. It's like a condition. Okay, but finish simplifying. Yes, we can cancel out this common expression. For any value of x you plug in here, the top and bottom will have a matching factor. So we can cancel those out. However, you have to keep the domain of the original expression where they are not equivalent. So even though we're going to simplify this to 9x over 2, we still have to keep the domain that x cannot equal -1. Okay, if we didn't keep that domain, this expression is not technically equivalent to that expression. So it's really important to keep the domain of the original function. Okay, let's try our next example. I can see we've got some quadratics. We have lots of things with addition or subtraction in the top and bottom. Now remember, again, you cannot do that. Please don't do that. There's addition or subtraction. There's lots of operations that would need to happen in the top and bottom first before we can do that division. So we need to factor these. And yes, they are both quadratics, and I believe they're both factorable. The two numbers that multiply to 6 and add up to +5 are 2 and 3. X plus 2, x plus 3. Nice, easy factorable one to start. In the denominator, we need two numbers that multiply to -33, so they're opposite signs. And they need to add up to -8, which means the bigger number is negative. And I'm going to say that's -11 and +3. Just double checking, they do multiply to -33 and add up to -8. Perfect. Okay, before we look for anything to cancel out, we want to state our domain. And it's going to be easier to see what value or values of x make the denominator 0. So off to the side, we're just going to take each factor. What makes that equal 0? So what makes x minus 11 equal 0 when x is +11? And what makes this factor 0? What makes x plus 3 equal 0 when x is -3? So for our domain, we can say it's all real numbers as long as x does not equal -3 or +11. Any other value is fine. Making the numerator 0 is fine. 0 over anything is 0. Except for 0 over 0, which is undefined, but probably won't run into that one. Okay, so then we look for common factors. Again, we have things held with multiplication, and I can see we do have matching expressions we can get rid of. So we can simplify this to x plus 2 over x minus 11 as long as we keep that domain. So remember, this is not equivalent to the original if we didn't keep the domain of the original. Okay, yes, so now in the simplified version, it looks like x only can't be +11. But again, it is not equivalent to the original if you change the domain. Okay, so we have to keep that restricted value. All right, let's try our next one here. So again, we want to factor as completely as possible. And up at the top, hopefully we remember our difference of squares. X plus 3, x minus 3, pretty common one. Now down below, we might notice that this looks very close to a factor we have up top, but it doesn't quite match. So what do you think we can do to instead make this a positive x? What could I take out as a common factor that would make it change its signs? We can take out a -1. And if we do that, that makes our x positive, and I'll put it in front just to match the form up top, but that would also make our 3 negative. Right? Dividing each of these by -1 would just change each of their signs, and now we can see we will have some common factors to get rid of. Okay, but our domain, what would make the denominator 0? Well, -1 will never be 0, but this expression could be 0. When does x minus 3 equal 0? When x is positive 3. So for my domain, x could be any number except for positive 3. And don't forget to put this slash. If you wrote x equals 3, then you're saying that's the only value you can equal, and in fact it is the exact opposite. It's the only value it cannot equal. Lastly, can we simplify our expression? Yep. We can get rid of the x minus 3's in the top and bottom, right? These quantities held by multiplication. So that gives me x plus 3 all over -1. Now, when you just have a -1 or positive 1 in the bottom, we don't need a fraction anymore. But we do need to multiply the top and bottom by -1 to get rid of the fraction, right? This would give me a positive 1 in the denominator, so no fraction needed. And we can go ahead and distribute the -1 here to make it -x minus 3. So this last part was really just simplifying it down so that we no longer needed a fraction, just applying that -1 to both terms in the top. We're multiplying top and bottom by -1 to get rid of it. And remember to keep the domain of the original. Even though there's no denominator here, x still cannot equal 3, or it's not equivalent to the original. Okay, our last couple examples here, we're going to talk about multiplying and dividing. So hopefully you remember when you multiply fractions, and that's all we're doing here, you're multiplying fractions, you just do the top times the top and the bottom times the bottom. Okay, multiplying fractions is relatively easy. Now we still want to factor these out though, because whereas I can tell 8 and 15 don't have any common factors, that's harder to tell when they're expressions. So in fact, if you had written this in its factored form, 2 times 2 times 2 is 8, and the bottom is 3 times 5, we can tell, hey, there is no common factors, or there are no common factors we can cancel. So this cannot be reduced. Now, when we do this with expressions, we're going to want to factor stuff out and then look for common factors. Maybe we can simplify the answer. So we're actually going to, rather than trying to say FOIL the top here with these giant numbers, we're actually going to factor them out first. So x minus 3, there's really nothing we can factor out of that, but I'm going to keep parentheses around it to remember that's its own factor. Okay, in the denominator here, we do have a common factor. There's a 2 that we can factor out of both of those terms. Dividing a 2 out of each of these leaves me with x minus 4. Okay, times. Now up top here, I believe 6 goes into both of those, so we can take out a 6 is a common factor. And that leaves me with x squared. Let's see, 6 goes into 9 once, with 3 left over, and 6 goes into 36 6 times. X squared minus 16. And then the bottom, is a difference of squares. X plus 3, x minus 3, pretty common one. And you might even notice, hey, we've got another difference of squares up here once we took our 6 out. So yes, let's go ahead and break that down as well. So this is the first fraction, not changing anything here, I'm just going to rewrite it. And then factoring out that x squared minus 16, that would be x plus 4 times x minus 4. And at the bottom, x plus 3, x minus 3. So now everything is as factored as possible. And remember, it's the top times the top, the bottom times the bottom, so all of these things are just being multiplied. You can essentially think of this as one giant fraction now. Just trying to connect the bars, where everything's being multiplied. And now that it's all held with multiplication, we can look to get rid of common factors. But before we do that, remember, let's write the domain of the original. So what value or values would make our denominator 0? Well, 2 will never equal 0. But when will this factor equal 0? When x is positive 4. So we need to exclude positive 4 from that. We're going to need to exclude negative 3 for that factor. And we're going to need to exclude positive 3 from that factor. So x could be any number except +4, -3, and +3. There's our domain. Now let's go ahead and simplify. So looking in the top and bottom, I see an x minus 4. Again, as long as everything's held with multiplication, they don't need to be right above and below each other. They're just common factors. I see an x minus 3 we can also get rid of. And the 6 and the 2 have a common factor, right? We really didn't break 6 down, but typically with numbers, we can figure them out without having to go to prime factors. If we divide each by 2, this would become a 1, and this becomes a 3. So looking at what we have left after we've gone through and simplified, the only things up top is we have a 3 times x plus 4, 3 times the quantity x plus 4, and you don't need to multiply that back through. And in the bottom, the only thing we have left is x plus 3. And since it's the only thing in the bottom, you can omit the parentheses if you want. If you wrote them in, it's not terribly wrong. They're just unnecessary. But the reason we might not multiply the top back together is just to show that there are no common factors for sure for anybody reading our answer. So that's it. Here's our simplified answer and our domain with the excluded values. Okay, so when you're multiplying, factor everything out. Top times top, bottom times bottom. You can start to think of it as one big fraction and then just cancel all your common factors after you've stated your domain. Okay, so hopefully multiplying is relatively easy. Let's do our last one here, which is dividing. So you may remember when you are dividing fractions, if you're dividing by a fraction, that is the same as multiplying by the reciprocal. Keep, change, flip, right? Keep the first one, change it to multiplication, flip the second fraction. Not a big fan of that, but multiply by the reciprocal, right? So now it's multiplication. Top times top, bottom times bottom. And of course, if you can simplify some things away, you would do that, right? There's a common factor of 2, and 6/5 would be the final answer there. Okay, so all we need to do in this problem to change it like a multiplication problem is to multiply by the reciprocal. So all we're going to do is flip this thing upside down. X squared minus 9, 15x cubed plus 45x squared. Okay, and then this fraction stays the same. Okay, now, let's go ahead and factor this out. Okay, so in the top here, it looks like we have a 5 and an x we can take out of our first fraction. And if we divide a 5 and an x out of there, from this term, we'd be left with x. Dividing by 5x, this would give me +2. Okay, so there's the numerator of the first part. Now down below, we have a quadratic. Let's see, the two numbers that multiply to -6, so they're opposite signs, and add up to -1. It's -3 and +2. Okay, so we factored the denominator here. Times, and now that we've already done our reciprocal, we have our difference of squares again, x plus 3x minus 3. And down below, let's see, we can take out an x squared as a common factor there. Oh, whoops, this is supposed to be 45. Apologies. Actually, we can take out a 15 and an x squared. So if we do that, taking a 15x squared out of that would leave us with x. And dividing that by 15x squared would give us +3. So here are all of our factors. All of these things held with multiplication. Remember, this is really one big fraction now when we're multiplying. Top times top, bottom times bottom. And let's state our domain before we start getting rid of things. So what would make the denominator equal 0? Ooh, well, don't forget we're going to have to do some extra stuff here. But we need to exclude +3 from that factor. We need to exclude -2 from that factor. We need to exclude -3 from that factor. Now 15 will never equal 0, but x squared, when would that equal 0? When I plug in 0 itself, right? 0 to any power would be 0. So this is what I have from my denominator here. But remember, x squared minus 9 was originally in our denominator as well. So we would need to exclude +3 and -3. Now, they're already in my list, but if they weren't, we would need to add them in. Anytime anything is in a denominator, an expression is in the denominator, there is a restriction on that variable, whether it be in the beginning or when we flipped it upside down, those both have to have it. In fact, the reason that both the top and bottom of this fraction can't equal 0 is because even if the top equals 0, we would be dividing by a fraction that has a value of 0. You can't divide by 0. So a good typical rule is just to say anytime anything is in the denominator, we need to exclude the value that makes it 0. Okay, our last part here, of course, let's simplify this. I see an x plus 3 we can get rid of. I see an x minus 3 we can get rid of. I see a 5 and a 15. If I divide each by 5, that gives me a 1 and a 3. An x plus 2 we can get rid of. Wow. And in fact, we have 1x, x to the first, and x squared. We can get rid of 1x between the top and bottom. And wow, what a big mess. But I think up top, the only thing we have left is a 1. And in the bottom, we have a 3 and x to the first power. 1 over 3x. That entire giant expression, all those calculations can be simplified into doing 1 divided by 3 times x, as long as x does not equal any of those restricted values. This gives me the same answer for x as this does, except I would have to exclude those values, right? But you can tell, I mean, if I'm writing a computer program and I need to do all of this, and I can instead do this and just tell it to skip those numbers, that's a heck of a lot of saving of time and computing power. Okay, so when you multiply, factor out top times top, bottom times bottom, state your domain, cancel your common factors or reduce them. Same thing when we were dividing. Multiply by the reciprocal, flip this upside down, right? That's how we got this. Factor it all out, look for common factors to get rid of. Don't forget to state your domain and exclude anything that was ever in a denominator. Okay, hopefully this lesson is relatively easy to understand. This chapter is going to get much more complicated, so please make sure that you have a good understanding of what we talked about here, what you can cancel and what you can't cancel. Because next lesson, when we add or subtract, it's going to be a lot more difficult than this lesson. I wouldn't say it's crazy difficult, but you definitely need to understand this to move on. So if you have questions, make sure you ask in class.